if you are looking for some support for current affairs, if you are a fresher, you are a working professional, you are a repeater but you want some support for current affairs, then I have a program for you. I have given the brochure and also the announcement video link in the description. You can watch if you are interested. Hello all, welcome back to Current Affairs Hitlist series. I'm Guna Mathivanan from Officers IAS Academy. In today's video, we are going to discuss about supercomputers. So before understanding about supercomputer, let's understand about computer first. The computer has a lot of parts. The most important part is the central processing unit. We all know central processing unit. Now the most important component of the central processing unit is the processor. See, we all we know that Pentium processors, i3 processor, i5 processor, i7 processor. You'd have heard about these processors. Okay, so computer has many components. The most important is the CPU. In that CPU, the most important part is the processor. Okay, now this processor, how it works? This processor has a switch. It will have a switch. Okay, normal switch. Okay, fan switch, tube light switch. Think like that. Imagine like that. Now, if you have one switch, what you can do? You can switch it on or you can switch it off. These two operations you can do. So if I have one switch, I can do two operations. I can on, I can off. For on, I am giving the number 1. For off, I am giving the number 0. I am giving the number 0. Assume that I have two switches. So what I can do? I can switch on. I can switch on both the switches. On. Okay, I can switch on one switch, I can switch off other switch, on off, similarly off on, or I can simply off both the switches. So when I have one switch, I am able to do two operations. When I have two switches, I am able to do 4 operations. Are you able to understand? I have two switches. I can keep both on, or I can off one, I can keep another one on, or I can keep another one off, I can keep another one on. Or I can simply switch off both. I can do 4 operations. Now let's assume that I have 3 switches. When I have 3 switches, I can off everything. I can switch on one. I can interchangeably, I can switch it on. So like that, I can make a combinations. Point what I'm trying to convey here. So here, if you will be getting around 8 different kinds of combinations. Right, so let's say 1 1 0 1 0 1 0 1 1. Okay, so like that the combination is going to go. So point is, when you have one switch, you are doing 2 operations. When you are having 2 switches, you are having 4 operations. When you are having 3 switches, more operations. So more the number of switch, more the number of operations. More the number of switches, more the number of operations. Here, instead of switch, let's use the term transistor. So a processor will have transistor, and transistor is nothing but the switch. A transistor in that processor will act like a switch. Right? Clear? So now, based on the number of transistors in that particular processor, the processor capacity is going to vary. See, more the number of transistors, more the operations it can do. If there is 1 transistor, it can do 2 operations. If there is 2 transistors, it can do 4 operations. If there are 3 transistors, 4 transistors, the number of operations is going to increase. Right? That we are able to understand. So now let's take this i3 processor. Now can you imagine how many transistors it is going to have? This i3 transistor, small chip i3 transistor, it has close to 1.4 billion transistors. That means 140 crore transistors are there in this i3 processor. That much transistors are there. 1.4 billion, 140 crore transistors. For 3 transistors, 4 transistors only, their operation is going to be more. Imagine if there's 1.4 billion transistors, how it would be, right? And today the most powerful, as of 2024, the most powerful processor, okay, that processor, it's very small in size. Maybe the size of the processor can be equivalent to that of your nail, okay, that too much size only, right? One of the powerful processor, the size of the processor, the size of the chip, it may be equivalent to size of your nail, okay, that has close to 50 billion transistors. 50 billion transistors, right? 5,000 crore transistors are present in that most powerful processor. But now, see, very fascinating, right? Very fascinating. But beyond a point, it is very difficult to fabricate more smaller transistors, right? So beyond a point, you cannot put more transistors inside that chip. Are you able to understand? Because there's no space. You cannot fabricate smaller size below a limit. Okay, once the transistor was this much big, it was reduced. Now in nanometers we are manufacturing transistors. We are trying to further reduce the size, but at one point you cannot reduce it beyond a limit. So in such situations, what we will do is, we will take two processors. We will take two processors. One processor, we have reached the limit, assume, beyond which we cannot add transistors. That much, the bottle is full. Now let's take two bottles. In the second bottle also we have more transistors. When you combine it together, the power is going to be more. You want more power, you add two more transistors, right? You mean two more processors. So in a computer only you can have, in a CPU processor only you can have 4 different processors. Are you able to understand? Or if you want to add 8, you can have 8 core processors. You want 16, you add. Depending upon the need, you can add. This is how today we are getting powerful computers. Okay. So let's assume that this is one powerful computer which has a lot of processors inside. It has a lot of processors inside. But even here, see, for our commercial purposes, right, this much is sufficient. But if you want to process mega size data, you want to process meteorological development, you want to process genetic codes, you want to process billions and billions and billions of data, you want to process billions and billions and billions of inputs, then you need more powerful computers. So what we will do is, okay, this is one powerful computer. We take with more number of processors. Now let us connect it with another powerful. Okay, let's connect it with another powerful. Like that, let's connect it. Now all this put together is called a supercomputer. So put it simply, multiples and multiples of processors linked together will result in that supercomputer. Okay. So supercomputers, their operational efficiency is calculated. Their operational efficiency is calculated using flops. Flops means floating operations per second. It is usually measured in the form of petaflop. Okay, supercomputers, their performance, their operational efficiency, their power is usually measured in the form of petaflop. So what is a petaflop? 1,000 trillion operations per second. 1,000 trillion operations per second. That is one petaflop. One petaflop is 1,000 trillion operations per second. Think about the capacity of supercomputers. So the supercomputers usually will be defined by referring to its petaflops. By referring to its petaflops. Right. So with respect to India, but before showing the India statistics, I hope you got clarity on this topic. Supercomputers, they are powerful computing device that processes data at a greater speed. They are measured through floating operations per second. They are used in research, artificial intelligence, big data. Right. So the regular computers will use something called as instructions per second, IPS. Supercomputers efficiency is measured using something called as flops, floating operations per second. Right. So this is I have given a picture of this is Summit, IBM Summit. This is one of the fifth largest, fifth powerful supercomputer in the world. With respect to their petaflop, I will reveal that in a short while from now. Let's see about India first. So, what is one petaflop? 1000 trillion operations per second is the one petaflop. So, with respect to India, the most powerful supercomputer we have is Pratyush and Mihir, two different supercomputers. In combination, we are using it. Pratyush and Mihir, both combined capacity will give you 6.8 petaflops. One petaflop itself is 1000 trillion operation per second. In the case of India, we have the most powerful supercomputer. That's a combination of two supercomputers, Pratyush and Mihir, which has a speed, efficiency or capacity of 6.8 petaflops, which is used for weather forecasting. Okay, largely it is used for this weather forecasting. Meteorological department uses it. All right. So now, why it was in news? India wants to achieve a 18 petaflop system. Already we have 6.8 petaflop system. Now government wants to have a 18 petaflop system. That's why it was in news. So now let me reveal. I was showing the fifth largest or fifth powerful, that is what the right term, fifth powerful supercomputer in the world. That is the IBM Summit. This one what you are seeing here. What is the petaflop range, sir? It is 200 petaflop. It is 200 petaflop. Okay. So what about the world's most powerful supercomputer that is called as Frontier? That is called as Frontier, which is 1.1 exaflop. 1.1 exaflop means 1 exaflop means 1000 petaflop. 1 exaflop means 1000 petaflop. You know what is petaflop? Okay. You know what is petaflop? So 1 exaflop is 1000 petaflop. The most powerful supercomputer as of now in the world is Frontier, which is 1.1 exaflop. Okay, so now just compare with India. So now we are planning to develop a supercomputer which has a will be having a capacity of 18 petaflops. Okay, hope you got clarity on supercomputers.